Hello and welcome to the Quick Start video tutorial for True Shape Nesting with VisualCAM 2014, brought to you by Mexsoft. Let's load the part file containing the geometry for nesting. From the main menu, select File and then Open. Find the part file named True Shape Nest Quick Start Tutorial located in the Quick Start folder and then select Open. The following basic steps are included in the nesting process. In VisualCAD, we have staged the necessary geometry on the screen for the stock material and one or more production parts. We will then load the VisualCAM Nest module and define the nesting type to be performed. Then we'll select the sheets to nest our parts in and then select the parts to nest. We'll choose our desired nesting parameters. Then we'll preview the nest, making any final adjustments. Finally, we'll commit the nest, creating the actual nested sheet geometry. Before loading the nest module, let's take a look at what we've done in VisualCAD to prepare for nesting. You can refer to this as the staging process. We have brought together and located on the screen the geometry that we want in the nesting process. As you can see, we have one or more shapes that represent the stock or the remnant material. We also have one or more shapes that represent the production parts that we want to nest within the stock material. Now, let's launch the VisualCAM Nest module. From the main menu, select VisualCAM and then Nest from the drop-down menu to display the nesting browser. Notice that the nesting browser is organized into tabs, representing each step in the nesting process. In this guide, we will be demonstrating True Shape Nesting, so we will select that option. You will notice a Help button located on each tab of the nesting browser. Selecting it will display documentation for each option on the active tab. From the Select Sheets tab, pick Select Curves. Now we select the shapes that represent the stock material and right-click to end the selection. Notice that entries are made into the table for Sheet 1 and Sheet 2. For the Count column, let's enter 2 sheets of each of these for the sake of nesting. The Start Corner and Nesting Direction columns allow you to control where the nesting should begin and in what direction it should proceed. This is good for remnant control. We'll come back to the Grain Direction column a little bit later. Next, we'll select our parts to be nested. Pick the Select Parts tab of the nesting browser and then pick Select Curves. Then we'll pick the exterior geometry of our parts and we'll right-click to accept those. We'll pick Select Curves again and select the interior geometry just by windowing it, and again right-click will enter those into the table on the browser. Here is a good tip about selecting your parts. Selecting the exterior shapes of all of the parts first forces them to be at the top of the list in the table on the browser. This makes them much easier to find later when you need to change parameters such as count, orientation, or grain direction. The interior geometry of the parts can be at the bottom of the list because you will likely never change these parameters. Now we'll enter the count for each of the parts that are needed in the nest. For part 1, we'll enter 6, 2 will enter 16, 3 will be 50, 4 will be 32, 5 will be 18, and 6 will be 16. There are 3 control options below the table that will apply to all of the parts. I'm going to change the incremental angle to 45 degrees. This means that the nesting software will attempt to rotate any of the parts in 45-degree increments to achieve a better fit. I'm going to enable the Mirror Parts for Nesting option. I will also enable the Allow Parts Inside Other Parts option. This will allow smaller parts to be nested within the cutouts of larger parts. If you have a part that you do not want rotated or mirrored, such as this one here, you can enable the Fixed Orientation. It will be maintained in the exact orientation that it is staged. Now we'll select the Choose Nesting Parameters tab of the nesting browser to set two final parameters. The first one sets the distance between adjacent parts. We'll enter 0.15 there. The second is the distance between the outermost parts and the outer edge of the stock material. We'll enter 0.25 for this parameter. Now we select Execute Nest and then Preview Nest as well, and notice that 3 sheets will be used. Notice that this part here was the one we fixed in this orientation, exactly as it was when it was staged. The last thing I would like to do is to impose a grain direction control on this larger part. In order to do that, I need to specify the grain direction on the stock material as well as the part. First, we'll go back to the Select Sheets tab and set the grain direction to a long X for both sheets. The system warns you that all sheets must have the same grain direction. Pick OK, and both sheets will be assigned the new direction. Then, on the Select Parts tab, I will set the grain direction on the part to be a long Y. Now, we'll select the Choose Nesting Parameters tab, execute, and preview the nest again, and we see that those parts are aligned vertical now. Let's look at the other sheets as well. Each time the nest is generated, the system will calculate an efficiency factor, referred to as % utilization, of the stock material. Once we're satisfied with the layout of the nest, we will select the Commit Nest button. This writes the geometry of the individual sheets onto individual layers in your current CAD part file. The geometry can then be used for machining or any other application you wish. This completes the Quick Start tutorial for True Shape Nesting in VisualCAM 2014. For further assistance, you can visit the online help supplied with the program or visit www.mexsoft.com for additional tutorials. Thank you.